Okay, so we're ready to get started this morning. I'll turn it over to Mary Lee.
Good morning, everyone. I am very honored to be here and chairing this keynote session this morning and introducing our keynote speaker, Mary Lee Wheaton. I work at the Aerospace Corporation and I head up our corporate university, the Aerospace Institute. Today, our speaker is Mark Daniels, who joined Intelsat General Corporation in 2008 as the Vice President for Engineering and Operations. I think many of you are familiar, but Intelsat General Corporation provides commercial communication solutions to commercial, government, and military customers through their fixed and mobile satellite systems, so a wide array of customers. Mr. Daniels, actually in terms of his responsibility, covers all the engineering and the operations activities for Intelsat General, and that includes program management, engineering management. They have a secure operations center that they use for their government customers. They also have operations in Hawaii and liaison activities with the Intelsat Engineering and Operations Management staff. Prior to joining Intelsat General Corporation, he had over 20 years experience at a number of other companies, including Veristar Government Services, Pan Amsat, Orbcomm, and ER Systems. So he came to Intelsat with quite an array of experience in design, integration, implementation, operation, and maintenance of complex hybrid satellite and terrestrial communication solutions, as well as launch vehicle and satellite design, so quite a varied background. Mr. Daniels earned a Bachelor of Science degree in Aerospace Engineering and an MBA from the University of Texas at Austin, and he is also an instrument-rated private pilot. You know, our theme is imagining the future, and when I was doing some research related to Intelsat Corporation, I saw that they are really trying to plan for, especially for both the commercial as well as the government customers, you know, secure solutions related to providing this kind of service. And one of the approaches that they had for providing secure services was that they wanted to anticipate, withstand, recover, and evolve. And in reading that, I really thought that that was a very good example of how we want to imagine the future. So with that, I'd like to have Mr. Mark Daniels join us up here for his keynote talk. Mr. Daniels.
Thanks, Mary Lee. Good morning, everyone. So it's a really pleasure to be here in this nice weather, 65 degrees. I came from the East Coast, and as I was leaving, it was snowing. It was like 28 degrees. And there's something that recently I've been traveling, and so far, every time I've traveled, it snowed back home. And so, you know, I guess that's good for me, but my wife was having to do the shoveling. So I think I might be in the doghouse over that one. But weather aside, this is an exciting time for our industry. We have 3 AEHF satellites already on orbit, 3 more to go. So they'll be providing our secure, survivable comms for the DoD. In the future to come, they'll be augmenting and enhancing Milsat, or Milstar. We have 2 MUOS on orbit now, and 2 more to go, plus 1 orbital spare. And one of the really exciting things about MUOS is the new waveform. So the WCDMA waveform is, you know, it's a 3G waveform. It's cellular. So it's going to provide 4 times the capacity of our current UFO fleet. If you think about that, we got 10 UFOs. You know, they're aging, but 4 times the capacity. So that's going to be a really great capability. Now, the terminals are still coming online, so you know we got to get that taken care of. We have 2 SBIRs on orbit now, and 4 more to go. So great capability there. And then switching over to what NASA's doing, NASA's working on a laser comms payload. It's already been tested between the Earth and the Moon at some very high data rates. So this laser comms payload can be hosted on GEO satellites. It can deliver 1.8 gigabits per second to airborne aerial vehicles. And even higher, it's 1.8 gigabits per second is not the limit. So they're already looking at how do we get to 10 gigabits per second. And we have SpaceX now that's launched 2 GEO transfer communication satellites. So, and then on top of that, Intelsat now has contracted with SpaceX for the Falcon Heavy, which is not developed yet, but we need that for our larger satellites. So there are a lot of exciting things going on, and unfortunately I can't mention all of them, but I think one of the things that really jumps out for me, that maybe could be revolutionary for us, is the progress that we're making in quantum computing. You know, maybe it's not quite a reality yet, but I think it's getting close. That could potentially revolutionize a lot of things that we do. So now, on the other hand, we do have some realities to deal with. We have budget constraints. We're living in a fiscally constrained environment right now that's affecting everything that we're doing, really, all of our work. So we're going to have to think differently. We got to get our terminal programs, our ground programs, in sync with our space programs. We can't afford to have, for example, MUOS terminals not ready yet for the CDMA. We have to use the legacy terminals right now on MUOS. So we got to get those in sync. And I think a recent quote by our DARPA director was pretty telling, that we can't afford to have our space and our ground system programs taking 10 years or longer to come to fruition and cost billions of dollars. And so we have to do things differently. We need to, I think, change the way we're doing things. And what I'd like to talk to you about today are some commercial ideas. Hopefully it can be some innovative food for thought of how commercial approaches can possibly help space systems and ground systems maybe do things a little differently. So I'd like to start with a recent quote from General Shelton. This is in January, and I'm just going to paraphrase. So he said basically, why can't all wideband communications be handled by the commercial satellite industry? And it's interesting that today, 70 to 80% of the military comms is on commercial. So that's sort of a fact. But what's different, I think, is that it's all being bought short term, and so it's expensive. It's more expensive than it needs to be. And so there's some things that can be done, multi-year procurements, longer procurements. There's an initiative right now called Pathfinder that's being worked on. And in this initiative, it's where the U.S. government is looking at actually buying assets, so buying transponders, buying satellites to get owner economics. And so, yes, WGS is also, wideband, but with the commercial side, transponder could be bought out for the life of the transponder, and then the government would get the owner economics of that. And then the second phase to Pathfinder is actually being looked at the possibility of the government buying a complete commercial satellite, and in return for that, getting access to the rest of a commercial satellite operator's fleet at the owner economic rates. And the other interesting part of that is that our media customers, they already do that today. So they have 15-year contracts with us, and they get those lower rates. They get those owner economic rates. So, and then all that's on good footing. Pathfinder, General Shelton's comments on good footing. If you look at our national space policy, and I'm just paraphrasing here, it's the government we'll use commercial services and products to help foster innovation. So that's what we're talking about here today, is to try to imagine the future, be more innovative. So how can commercial satellite operators help in this regard? Well, we have a pretty extensive ground network that supports our flight assets. We do have 51 satellites that are Intelsats, and then there's 25 that we fly that are third party for other people. And then underpinning all that, we have a pretty extensive architecture of fiber. We have 40,000 miles of MPLS fiber. It's got triple redundancy built in, so it's 2-fault tolerant. And we have to do that because of our broadcast customers. They're the ones that drive us. So with this, we get 5 nines of reliability, which maybe some of you didn't realize. We also have 6 owned and operated teleports. We use about 12 third-party teleports. We have a satellite operations center with that are basically located in diverse locations that can both fail over back and forth. Our op centers are the same way. We have multiple op centers to where if a problem happens in one, we can fail over the other. So with all this architecture, I guess what I wanted to say is that we do things a little differently because we have to, because it's commercial, we're driven by the bottom line. And you can look at our financial statements and find this number, but the entire investment that we make each year for the ground architecture, and this includes both of the, this is our fiber, this is our antennas, our teleports, it's even the CapEx, or the non-recurring that goes into our satellite programs, is 40 to 50 million a year. So, that's a pretty low number when you think about it. Now, of particular interest, I think, to many of you in this room is our satellite operations capability. Because we're currently, as I mentioned, flying 76 satellites and 14 different buses across those satellite platforms. And I think the thing that's most interesting to probably this group is that we do that with 100 people. And that's our entire satellite operations group at Intelsat. And that 100 is broken down with 40 flight controllers who also operate the ground network. And then there's 38 engineers, satellite payload engineers, there's 15 flight dynamics engineers, and then the rest are IT support for the systems. And so, one question is, and the other fact is that on each shift, on each flight operations shift, there's 8 people, and those are split between the West Coast and the East Coast. So we don't use a lot of people to fly 76 satellites and then operate the ground architecture underneath it. And so the question is, so how do we do that? Well, we've had a number of groups come in to ask us that question and to see how we do it, to kind of benchmark, our practices against your practices. And we encourage anyone who's interested to come and talk with us, because we've had Air Force, NASA, NOAA, kind of you name it. A lot of different groups have come in. More are coming in. We have an aerospace group coming in here in just a couple of weeks. So we're excited to show you how we do it. One of the keys is automation. And I'll talk a little bit more about automation, but these are our 2 satellite operation centers. So the one on the bottom is the East Coast. The one on the top is on the West Coast. So you see that they're not very big. When people come in and see them, they go, my gosh, you fly that fleet with these small centers? Now we're about to move the East Coast Center. We're moving to Tyson's Corner. And the whole CapEx for that project is like $10 million. So it's not a huge investment we're making there. And so we don't have a lot of systems. We have 2 real-time systems that are used to fly our fleet. The first one is called GNS, that's Intelsat's homegrown system. It's a ground network system. And we've been using that system now for 50 years. And by the way, this is Intelsat's 50th year of operations. So it's actually, so you'll probably be seeing more about that this year. It's our 50th anniversary, and so apologize for the plug there, but that system though is what our controllers like using the best. Well, we also use a third-party system called Epic. Probably a lot of you are familiar with it. It's from Kratos Integral Systems. But the reason we use that is kind of interesting. It's because that the third-party operators who come to us and say, we'd like you to fly our satellites, they want us to be on a system that is portable, so that if they ever wanted to take it back, they could, you know, it's already being flown on Epic, and then they could take that system back and use it themselves. So we try to minimize the number of systems that we're using. And then we have 4 legacy systems. So those are the stovepipes that we have, and we're trying to get rid of them. As our satellites are aging, these go back to some satellites that were delivered a long time ago, and we kind of have to keep using them until then, and I know many of you are aware of that problem. So we're phasing those out, going down to just the 2 systems ultimately. And then coming back to automation, that's really, I think that is really our key. You know, there's some other ones too, but the interesting part about automation is that it does help us do it with a few number of people, but it also helps us reduce human error. And that helps us increase reliability. And so what are some of the things we automate? We send like 25,000 commands a year, roughly, just for station keeping maneuvers. Those are all automated. The generation of those commands, the loading into the systems, the uplink to the satellite, it's all automated. Now, our flight controllers, they monitor that, so it's more of an exception monitoring, I think, than anything else. And yes, they can take over manually. They can do manual commands, but that's the exception rather than the rule. We try to keep automated. Ranging is automated. It's like underneath, you know, and the controllers don't really have to worry about it. Another example is telemetry collection, archiving, even response to anomalous telemetry commands. Not all of them, but some of them. I'll give you 2 examples. So like, for example, if a gain change on a transponder is made because of a bit flip, our system will detect that and then automatically send a command to change it back. And I mean, less than a minute, it's taken care of. Controllers are kind of out of the loop. They just see that it happened. And even more complicated versions of that, like a momentum wheel on some we know what satellites these are. Sometimes can get sticky, and when that happens, the signature of that telemetry is well known. And so then the system detects that, puts us in thruster control. We stay 3-axis controlled while that's dealt with, and so we don't lose earth lock. Because if we lost earth lock, that could be hours and hours of outages for our customer. So those are just, you know, a few examples of automation. But you know, that's definitely one of the most important things for us. And then the other thing I mentioned is that the fact that the ground network is all operated from these same control centers. So we have TT&C sites located around the world. I think in your world, you call this command and control. So we have 130 antennas that are pointed to our satellites. And each satellite has two antennas that are pointed to it, and they're in diverse locations. And in addition to that, there's a third antenna, and these are rovers, so it's not one-to-one. But these rovers are placed around the world too. So every satellite can have three command paths to it, 3 telemetry paths down. So we have 2-fault redundancy basically built into this ground network as well. Now, video, it turns out, is a big driver for commercial companies, commercial satellite operators. This is an example. It shows you a ground block diagram of a ultra-high definition test that we did. It's actually a live broadcast we did at the IBC conference in 2013. So this is the first time it was done. It was 100 megabit per second video, ultra high D, 4K, going through our ground network, uplinked over satellite. And one of the reasons that the reliability of our network that has been designed the way it is because of video. Because if you think about it, a broadcaster, they can't afford 1 second of video to drop out. You're watching the Super Bowl or the Olympics, broadcasters go nuts. I mean, we get the CEO of NBC calling the CEO of our company when something happens. I mean, it's like, you know, it drives how we design what we do. And so that terrestrial, you know, video over terrestrial is no easy thing to do. And so live video, that's why we have to have the triple redundancy built into our terrestrial network. So another thing of interest to this group, I believe, is the hosted payload area. There's a number of innovations that I think hosted payloads can bring to military and IC programs. This shows you 3 hosted payloads that Intelsat has done recently. Starting on the far left, we have the FAA WAAS that provides GPS augmentation over the U.S. We did a hosted payload with Cisco on IS-14. It's called IRIS. It's a router in space. And then most recently, we launched a UHF hosted payload for the Australian Defence Force. And going a little bit more into that, one of the benefits of hosted payloads is schedule reduction and cost reduction. And we have to fly on time. I think that's one of the key things a commercial satellite operator brings to the table. It's for us, we have to replace our fleet on time. We can't wait. When we have to launch, you know, the train leaves the station. So payloads have to be ready. So we did the ADF payload. It was, you know, it's an existing payload. No development work was needed. Less than 3 years from contract signing to on-orbit capability. And as a result, you know, costs are contained. And the Minister of Defense at the ADF was quoted saying, "You saved $150 million over the cost of what it would have taken had they gone the free flyer approach." So that shows you, you know, I think one of the benefits of hosted payloads. Some others are disaggregation. So basically, let's not put all our eggs in one basket. Let's spread around the capabilities that we have, so we just don't put them all on one satellite and where our adversaries know where it is. Let's put them on commercial satellites, multiple orbital locations, and we can fly almost any payload. We've looked at EHF, we've costed it out. We know what the swap is. We know orbital slots we can fly it to. IR sensors can be flown. SSA sensors can be flown. So a lot of opportunity here, and I think, you know, with the opportunity to increase resiliency and lower costs and bring schedules in as well. And then, you know, further backing that, it's, you know, our national space transportation policy is encouraging all of us to really look hard at this. Intelsat has launched average of 3 satellites a year now for 25 years. So we've been doing this a while. Each one of those opportunities can be used for a hosted payload. So we have a fleet plan, you know, and we share that fleet plan with anyone that's interested. It shows when our satellites have to be replaced. We can pull some of those forward too, if need be. We can't be late because you know, if we're replacing a satellite, we got to make sure we're early, you know, or just in time. We always try to be a little early. And we've probably used, you know, all the vehicles out there. We definitely focus on reliability. We recently had a launch failure on sea launch. with IS-27. So, you know, we haven't had a perfect record, but that was the first failure that we had in over 15 years. So we've, knock on wood, had a pretty good record. Right now we're focused on Ariane 5 for our next launches. And then past that, we're focused on SpaceX. We're very excited about that. We think SpaceX is going to help lower the cost of access to space. We already see this. Ariane 6, they're already starting to look at how do they lower their cost. So this is driving some innovation right there. The Falcon Heavy is going to fly, hopefully in the next few years. And we could fly on the Falcon 9, but those are smaller satellites. So most of our satellites are bigger and need the Falcon Heavy. And then for payloads that need U.S. launch vehicles, I think, you know, SpaceX is going to be a low-cost answer for us. And of course, we have Atlas and Delta. It's just that the cost is a little higher. So, cybersecurity, I couldn't talk to this group without saying something about cybersecurity. And I know it's important for government, and it's also important for commercial. We, turns out, have a very strong information assurance program. And you may not have known that, but we've had to do this. We have to protect our network. We have something like, I think it's like 100,000 denial of service attacks, you know, a year that are constantly pinging our network. And so we have systems in place by that. We were attacked by the APT threat. And so we had to deal with that, shut down our systems, put the monitoring in place. So we have very strong posture here. We've taken the DoD 8500 standard and the ISO, I think it's 27001 and 2. And we've taken the most stringent controls from those standards and implemented those across our network. So as a result, we operate a number of DoD circuits within our group that are at the Mach 1 category, so the highest mission assurance category. So we have command encryption turned on the satellites, and then certify that our networks are audited and tested, you know, against the standard, against all of the controls that are needed. And here's a recent example of a program we did for CBSP. This is a Navy program. So we did a Mach 2 implementation here, so it's kind of the next level down mission assurance category, which there's a lot of programs that fall in that category. But we had to look at our satellites, you know, as sort of an enclave, commercial teleports, our fiber network, and then of course the government enclave, the NICTAMs, the Navy NICTAMs, and you know, because we're putting hardware in there, hardware in our teleports, and of course everything's encrypted, you know, from the ships all the way through to the NICTAMs. So you know, that's all encrypted traffic flowing through our network. But these approaches can be used for hosted payloads. We do this today in the IC community as well. So wrapping up with some concluding remarks, I think we should take a look at Kelly Johnson's rules for the road, and maybe we need to go back to doing more programs like this. And it's interesting to look at the comparison between Skunkworks' approach and the commercial approach that we use at Intelsat today, and I think other commercial operators do it similar ways. And I won't go through all these, but we do use a small number of highly skilled people. One of our other traits is that, you know, we streamline requirements, but we have thorough requirements. Our requirement spec that goes into the satellite manufacturers is very thorough, and of course it's been developed over 50 years. And then our test plan is very thorough, been developed over 50 years. But then past that, we streamline a lot of the documentation, so we don't require a lot of reporting and documentation coming back. We use the existing processes within the spacecraft manufacturers, and we put small teams, and we embed those at the spacecraft manufacturers. And they work together as a team, and they speed up the decision processes, and we hold them accountable for their own quality processes. But we don't ask them to do anything different than that. And so that's how we get things done, I think faster and cheaper in the spacecraft world. And we use similar approaches in the ground system world as well. And so I guess, my final summary would be that if we can think about just streamlining the way we do things, doing things more commercially, maybe going back more like Skunk Works approaches, we can help improve our resiliency. We can help add more capability. We can reduce our schedules, and then we can lower our costs. Thank you.
So I know this is a crowd that is not shy, and so now is your chance to ask Mr. Daniels any questions you might have about Intelsat or their further information about the 76 satellites with 100 folks, or So, Mike, you have a question? And also, would folks please give your name and what organization you're from, and then ask your question.
Hi, Mike Campbell, Aerospace GPS Program Office. I was focusing on one of your last charts there where you had that comment about specifications in advance of contracting. And I'm just wondering if you're in a relatively stable environment like communication satellites where it's not a radically new mission every 6 months, I can see how that would be very beneficial. I'm wondering if you have encountered any situations where what you were trying to accomplish was evolving more quickly, where maybe defining all the requirements up front maybe wasn't the right answer, and you had to use something more like what in software might be called agile or something like that.
So yeah, that's a great question, and we are dealing with that in the hosted payload area, and so our preference is for the hosted payload development work to be done up front and be kind of frozen before you come and contract with us. However, we have had to deal with that on the Cisco Iris project. It was not fully developed, and it was going through its PDR, CDR testing program, kind of along with the spacecraft PDR and CDR. And then we had an off-ramp, which was to put a mass simulator on the spacecraft if they didn't make it. And so they knew that, and then we had some other flight opportunities for them after that. But so what happened is that they went through environmental tests, and so there was a lot of focus on they had to pull in some people to help speed things up and get through environmental tests more quickly, and they made it. But that was I think close, and if a payload were to get delayed, we have some flexibility. But most of that flexibility is with finding the next satellite that we launch. There may be some satellite flexibility with the current satellite, but that's going to be if we pulled it forward. So let's say we pull the satellite launch ahead by a year. Then we have some flexibility to say, okay, we can take a 6-month delay, something like that. But our preference is certainly to bring payloads that are developed and ready to go.
I'm Nelson Lau, Aerospace ERN. One question, you have 2 operation centers. Are they designed to, just in case one blackout, the other one can handle the whole load?
Yes. I should have mentioned that. I think I had intended to say that. But the way our operation centers work is about half the satellites are flown from the East Coast, and half are flown from the West Coast, and they can both take over each other's satellites, so we can fail from one to the other. Both of them can fly the entire fleet, believe it or not. So, and we practice that. So we do failover tests on a regular basis to ensure that our teams are trained and ready to go on that.
I'm Joe Betzer from the Computers and Software Division of the Aerospace Corporation, and I work a lot with the SMC Chief Scientist Office. I wanted to ask you a little bit more about your experience with hosted payloads. I assume that many of your customers have proprietary data. What do you do to separate the data, protect other users from getting the data of other users?
Yes, okay. So that's something that Intelsat General deals with a lot. So we're a proxy company. Everybody in our company has clearances. The parent company, Intelsat, is considered a foreign company because we're based in Luxembourg. So we separate information. So the way that works is that information flow can come from Intelsat to Intelsat General, but then the other way it's constrained. And so we can retain classified information, proprietary information within Intelsat General. And then most of the spacecraft manufacturers are able to handle that as well, to where we can deal, like if a classified payload is needed, we can deal directly with the groups at those manufacturers that deal with that.
Hello, I'm Brett Miller from Space Development and Test Directorate, and my question is, with respect to automation, what level of training, or what do you do to maintain operator proficiency?
Sure. Well, so there's, we do have in-house training person as part of our team. I think we have, it's one person, but we're doing constant training during the year. So there's cycles of it, and every controller is trained on each system and across buses. And we have experts on certain buses as well. But there's constant cross training that's going on during the year, and and that includes it's not just monitoring all the automated systems, but it's also doing manual kind of work as well. And one final point on that is we do have satellite simulators for each one of our spacecraft. Some of the older ones are harder to maintain, but those are used as well as part of training.
Thank you. Any other questions for Daniel? Yes? Right.
What are your recommendations for managing change and taking risk?
Frank works at Aerospace.
Ah, okay. Well, so managing change, we do have configuration management within the company, but I think it's done a little bit more commercially. So in the spacecraft side, we have it, and also within Intelsat General, we have it, and we leverage the spacecraft manufacturers to manage change within their spacecraft programs. We're mainly managing the change on our ground infrastructure and our terrestrial infrastructure, and we do it a little more commercially. But and then in terms of taking risk, that's a great question, because we do take risks as satellite operator. We're not trying to drive out that last 0.0001 of reliability. We have to accept risks. We've had launch failures, but we also have to deliver high reliability. And so I think one of the ways that we try to address the risk question is, we try to test as we fly. And I know aerospace knows that very well. We try to have comprehensive test programs. We try to test all our interfaces. We try to use flight-proven hardware to the maximum extent. And we build in two-fault tolerant failures on both our spacecraft and our ground system. So I guess those are some of the ways.
Yeah, Judy Kerner, I'm another aerospace person. Just wondering if you have any thoughts about characterizing the fundamental difference between a commercial and a military space system and or space approach. Why Intelsat can do it differently, and why there aren't many more than Intelsat trying to do it?
Well, I think Boeing is talking about this same approach. Craig Kooning was recently quoted as well, working on how Boeing could be working with the government on commercial approaches as well. And I think he talked about block buys, for example. That's one of the things that we do. So our recent Epic spacecraft, that's high throughput, we contracted for 4 satellites from Boeing, and so we save money. So that saves like about 30% on all the parts procurements right there, because we get well, they're all bought at the same time. So that's a big savings. And so he was saying that could be used in the government world, and the fiscal environments right now I think are maybe not making it so easy to do block buys. Now maybe on hosted payloads that could be a different story. And then in terms of controlling schedules, he talked about that as well. That schedules could be brought down. They don't have to be, let's say, 7-year schedules. They could be 3-year schedules if you do things a little bit differently. And I think it's some of it is requirements, documentation, that sort of thing. But it would probably be a good study to do.
To find out why anybody would want to move to Tyson's Corner. I drive by there every day.
Yeah, that's we're wondering the same thing. But no, seriously, we're excited about the Tyson's move, because we've been in that old Intelsat building now for 50 years. Well, not 50 years, but we've been in there a long time, and it's kind of showing its age. So it's a nice opportunity for us to move into modern space, and it gives us a chance to upgrade our systems as well. So for example, we had all of our spacecraft operation systems on the East Coast hosted there in the building, with power backup. Now we've moved it all out to our mountainside teleport in Hagerstown. So that was an improvement. That was a reliability improvement right there to make that happen. So now in the building, it gets everybody together. So in the Intelsat General Group, we're separated from the proxy, and it makes communications difficult. We'll be on a separate floor, but we still have all these visit requests and information exchange issues. But it will improve communication for us. And the third part of it that we're hoping to achieve is sort of a culture change, because Intelsat has started out as a big bureaucratic organization, and then PanAmSat came in and kind of changed things. Now we're public, and we're trying to do things differently. So we've been working on that integration now for 7 years. So I think hopefully this is going to take us to the next stage of that.
Well, we do want to thank Mr. Mark Daniels, and the good news is that he is staying throughout the day. So if you see him during the breaks or at lunch, or he'll be joining one of the working groups, we'll have him with us all day today. So if you think of any other questions you'd like to ask him or talk with them, we will have his company all day. So again, thank you very much for providing this keynote this morning on commercial innovative approaches. Really appreciate it.
Thank you.